This is the Lumidax FOS 1138. It is a complete trainer. It has a color TFT module. It has a function generator. And it also has some little bells and whistles here for your electronics projects. Now, let's go over some of the functionality here. We have a basic oscilloscope mode, and it's got several ranges from 10 milliseconds per division all the way down to, and look at that noise there, all the way down to 100 microseconds per division. So it's got a bandwidth of about 25 kilohertz, maybe a little bit more there. Anyway, it's perfect for analog teaching and also for your home projects as well. This also features a spectrogram, so let's take a look at that for a moment. I'm going to turn the volume down here a little bit so that we can see our signal. And there it is. You can see that if I change the frequency, it moves up and down. I'm going to change the sample rate to 10 kilohertz, and I'm also going to change the range of my function generator here so that we can actually see that signal. And you can see it very clearly that we're moving around. And that's a pure sine wave. Now, if we go to something like a square wave, you'll definitely see the harmonics involved there. If I tune it down to 1 kilohertz, here, let's go to another range. If I tune it to 1 kilohertz, you can definitely see other peaks here at 3 kilohertz, 5 kilohertz, 7, and that kind of matches up theoretically with what a square wave is. It's just all odd harmonics. And if we go to like a triangle wave, we can see even harmonics. And a ramp wave, of course, has a different pattern as well. So there's our ramp wave. Now I'm going to increase the level there. So we can definitely see that's working. All right, this also features a waterfall mode, which is a special type of spectrogram that shows time variations in your signal. So right now we can see the harmonics here. If we change the frequency, we can see it actually move up and down. So you can see those harmonics kind of pinching close together when I decrease the frequency. So let me go over the function generator. The function generator has 7 different waveforms. So I'm going to go back to oscilloscope mode for a moment. Alright, so I've got an amplifier hooked up here. It's basically just an op amp with a gain of 10, and I'm feeding in the output from the function generator to the op amp, and I'm also going to read the output here. That's the yellow trace. So the input trace is this kind of reverse ramp, and the output trace is this forward sloping ramp, and that's just because I'm using an inverting amplifier mode here. So it is actually inverting, and that oscilloscope is showing that. Again, a very useful feature of this trainer is the fact that it actually includes an oscilloscope so that you can visualize these circuits that you're working on. Now the function generator, back to that, has 6 different ranges from 1 kilohertz to 2 kilohertz, 4, 8, 16, and 32 kilohertz. And again, it has 7 different waveforms, so we're going to go over some of those now. We've got a pulse waveform. You can see the input pulse. Here, I'll move that. You can move the traces around pretty easily. So this white dashed line is the trigger line, and it auto triggers on channel 1. So I'm just going to move this other trace down. So that's our input waveform. It's a pulse. And then we also have a noise source, very useful for audio stuff. The noise source is useful also for, say, experiments that require a random variable. We have a ramp wave, a reverse ramp, a sine wave. This is a very nice sine wave. It's very clean. A square wave, and a triangle wave. And this is just useful for your different amplifiers and filters, showing what happens when there is some kind of RC type of element in your circuit. It's going to round off the edges of those sine waves and stuff. So anyway, let's try that. I'm going to make this op amp amplifier here into an integrator. And now we can see that it's integrating. And if I increase the amplitude of the input, we see that the output kind of resembles a sine wave, and that's just because I've added a capacitive element. Okay, that's the Lumidex trainer.